Welcome CS225 students. What I'm going to do is to describe how to use arithmetic in the C++ language. Now, by all means, if you have any questions, go ahead and ask them. No problem. Even though I'm recording, I'm going to edit a lot of this stuff out. All right, so I type in CS225 082715 arithmetic. I'm going to click OK. The next thing I'm going to do is I'm going to make a console application. So I click Next, and then I have a console application. I want to make sure that it's empty. So I click Empty Project, and then I click Finish. Now that I have this, I've got to actually create the C++ file. To do that, you need to open up the Solution Explorer. Hey, Professor Solis, I don't see a Solution Explorer over here. Somebody probably accidentally erased it. That's okay. You can go back over here to View, and then just simply click on the Solution Explorer, and there it is. All right, so under Solution Explorer, you will see Source Files. With this Source Files folder visible, right-click on it and hover on top of Add, and then hover on top of New Item. Because what we're going to do is to create a C++ file. So I click on New Item. It's already got the Visual C++ section selected. I'm going to select C++ file, and then I will leave the name of this as source.cpp. But if you wanted to change this to something else, like, Pac-Man or in Space Invaders or whatever program that you're creating, by all means, you can create that right here. I'll leave it as source.cpp and click Add. So now you have your C++ file. Pretty much every program in this class is going to begin with the following programming statements. Include IOStream. Using namespace. std. Int main. System pause. Return 0. So you will start off every program with this, and then you'll add to it as your program develops. Well, one of the things that I'll want you to do is to create comments. So let's say, for example, I have my declarations. Get user input, any type of calculation that must take place, and then finally output. For declarations, that's where you are declaring your variables that you're going to be using in your program. We talked about several of those different variable types, like integers and doubles and floats and so forth and so on. So let's go ahead and say operand 1, int operand 2, int result. Operand just simply means, in a mathematical statement, like for example, 2 plus 3 equals 5, 2 and 3, those are operands. The plus, that's an operator. And then, of course, since you're adding those two numbers, you would have a result, which is a sum. So operand is just a fancy, schmancy name that just simply means the numbers in the equation that you're going to be using. So 5 plus 4, the 5 and the 4, those are operands. All right, I want to ask the user to enter the value for operand 1 and operand 2. But I won't actually say that. I won't say operand 1, operand 2. I'll just simply say this. Cout to the user, enter integer 1. I'm asking the user to enter a number. Now, by saying integer, that means whole number. You know what? Maybe the user doesn't understand that integer means whole number, so I better say this. Enter whole number 1. And then I'll obtain that value. So that's the cin command. And we're going to put that into operand 1. So what this does is it outputs a request to the user, and it's going to input from the keyboard. That's what this is. And it's going to put it into operand 1. All right, so here, I've got to do the same thing for the next number. So cout. In fact, why am I doing this? Let me just copy and paste. Take this, Control-C, Control-V, and I'll just change this to number 2, change that to the number 2 as well. I'm asking the user to enter in two numbers, two whole numbers. Well, once I've got that, I can go ahead and perform a calculation. So for the calculation, that's simply going to be the addition of those two. So result is going to be assigned operand 1 plus operand 2. You notice that I'm taking advantage of Microsoft's IntelliSense. Let me talk to you about that a little bit more in detail here. When I type in OPER, I'm not going to type anything more because you see that operand is already selected. So I hit Tab on the keyboard. When I hit Tab on the keyboard, it selects that. Plus OPER. Look, operand 1 and operand 2 are listed. I'm going to use the down arrow to select this guy. And now I'm going to press the Tab button on the keyboard to select that. Now, could I double click or just continue to type? Yeah, I can do that. Make sure you terminate in a semicolon. Yes?
The equal symbol will be assigned in this language.
It's an assignment operator. Yeah, so you read this from right to left. Add this number plus this number, assign this to result. Yeah, so we call this the assignment operator. Well, now let's display the result in the output section. So what we'll do is we'll say cout operand 1. I'm going to send a plus symbol so that it looks like 2 plus 3 equals 5. So I need to present it like this with an equal symbol, and then finally whatever the result is. And then I'll put an endl statement, which means go to the beginning of the next line. So this, if the user entered 5, if the user entered 3, this would display 5 with a plus symbol, 3 with an equal symbol, and then the result, that was performed over here, so the result would be 8. So if I run the program and build it, and let me move this over here so that you can see, goodness gracious, why is that so big? All right, I'll fix that next time. Enter the whole number, 5, enter. Enter whole number 2, 3, enter. 5 plus 3 equals 8. And the reason why we see that is because this number over here is the 5 that was entered by the user. This over here is just simply a string with the plus symbol in the middle. That's why we see that over here with the space before and a space after, because I've got a space before and I've got a space after. What else am I going to send out? The value of operand 2. Well, what is the value of operand 2? It looks like the user entered 3, so that's why we see a 3 here. Let's send out an equal symbol with the space before and after. That's what we see over here. And then finally, let's send out whatever that result is. Well, we calculated the result. 5 plus 3, result is now going to be 8, and that's why we see the number 8 over here.
I've got a question.
Yeah.
What did you do to actually call up that screen with that you entered the data to?
Oh, I ran the program. So what I did was I clicked this guy over here, or you could go to debug and start debugging, or you can press F5 on your keyboard. So what I did is I clicked this, and then this console opens up, asking me the questions that I've asked it to present. So 2, enter, 3, enter, 2 plus 3 is equal to 5, press any key to continue. Yeah, question?
Why didn't you have to do the end line after the
Very, very, very good question. Why didn't I do this? Like, endl here, or maybe endl here. Because cin automatically has a built-in endl. When you type in a value, what key do you press to enter that value? You press enter, right? And so what does enter do? It goes to the beginning of the next line. That's why I didn't put the endl there. Because I know that when I press enter, it's going to take that user's entry and go to the beginning of the next line, which is exactly what enter does. Yeah. Good question. Other comments or questions?
Can you scroll a little bit down?
Sure.
You have to put system on.
Yeah, the reason why we do this is because when you run the program, you want to be able to see what it looks like. And so this is kind of like a dirty way of displaying whatever it is, forcing the press any key to continue to display on the screen. Otherwise, it would just simply display and go away. It would just flash it, and we don't want that. So I entered this line on purpose to allow you to see what it is that you've run. Question?
How does the computer know that the pause is when it's in parentheses? Doesn't that really mean like text? How can it tell if it's is that just submit an action?
So what happens is the Windows operating system has all kinds of commands that are available from a system perspective. Clear the screen. Pause. So if you wanted to, you could do a Google search for all of those system functions. So one of them is CLS for clear the screen. Other comments or questions?
Now, is there any way you can get rid of that press any key to continue?
Yeah, I don't have to put this at all.
Oh, that's the system pause?
Yeah. And just disappear. Yeah, let's try it out. 2, enter, 3, enter, but that's gone. That's why I like this, because it'll at least stop the program so I can see, is the expected output supposed to be there, and then I can investigate it, then press any key to continue. All right, let's try something a little bit more complicated. Go back over here and type in double. You guys are going to have to help me out. If I want to say 6 divided by 2, of course that equals 3. 3 is the quotient. What is 6 and 2? Are those called divisors? I think those are called divisors, if I'm not mistaken. Dividend and divisor. So the first one is a dividend, the second one is a divisor. The answer is a quotient. Okay, I like that. Thank you. So dividend. Is it D-E-N-D, like that?
Yeah.
That's how you spell it.
Divisor, and quotient. So the first number, the second number, divide those two, you get a quotient. Okay? And so I'm going to ask the user to enter in numbers that I can divide, and let's investigate to see what happens. And that should take us up to, this class gets over at 11:05.
Yeah, don't you say?
Good. Double check. Yeah, 11:05. All right. So now let's do this. Let's have the user, so we'll say C out, enter the dividend. We're going to C in and put that into dividend. Similarly, I'll ask the user to enter the divisor, which is the second number. Put that into divisor. Okay, so now that I have these two numbers given to me by the user, I want to be able to divide this divided by this, and then calculate whatever the answer is. So over here, we'll say quotient is going to be dividend divided by divisor. So I have the quotient, and now I want to output that result. So over here, I'll just simply say C out, whatever that dividend is. And I'll put this as the division symbol. Divisor equals, and then whatever the quotient is, followed with an end-del to go to the beginning of the next line. So I'm showing the addition of two numbers, I'm showing the division of two numbers. All right, so let me save my work by clicking Save All, run the program, build it, enter a whole number, 2, enter a whole number, 3. Okay, enter a dividend, 4.5. See, that's the nice thing about doubles, which is what that is over here. These are doubles. Doubles can accommodate real numbers. Enter. Enter the divisor. Okay, 2.1. Press enter. Okay, so 2 plus 3 is 5. 4.5 divided by 2.1 is 2.1426. So what is 4.5 divided by 2.1? 2.142, and it's rounding up that 5 to 6 because there's a 7 there. Okay, good. Looks like it works. Calculator. Press any key to continue. Yes?
Is there any way to make the numbers go farther out?
Yeah, there is. Yeah, we'll get into that, about how maybe I only want one number after the decimal point or several numbers after the decimal point to make it so that it's got more significant digits.
So it pretty much like assumes a certain decimal point.
It doesn't assume. It'll take whatever the type of the data is, and based on that, it will go out a certain number. All right. Let me run this program again. And this time, I will use, let's see. What I want to do is I want to see if I can get an integer answer. Okay, how about this? Run the program again. I type in 2 and 3. All right, 5 and 2. Now you know that 5 divided by 2 is 2.5. But the question I have for you is, are those whole numbers or are those real numbers? Those are whole numbers. You don't see 5 point something. You don't see 2 point something. So then how come the answer is not 2 as opposed to 2.5? Well, what happens is, sorry? No, go ahead.
It's already like there is the double.
Very good. Very good. This is a double. So when I type in 5, that 5 is really not 5. That 5 is what?
5.0.
Very good. Very good. When I type in 2, that number really is not 2. That number is?
2.0.
Okay, now let me try to trick you. When I type in 5 over here, is that number 5 or is it 5.0?
That's
Then it
fine.
really is 5. Yeah, because I'm saying, hey, I'm going to treat you as if you are a whole number. You don't have a decimal point. I'm going to treat you, whatever you give to me, as a decimal number. And if you give me 5, I'm treating you as 5.0. So 5.0 divided by 2.0, that makes sense, 2.5. Okay. So that's called implicit casting. We're going to talk more about casting next time because it may very well be that you want a deliberate integer even though the user gave a whole number answer or a whole number quantity of numbers. For example, my son goes to the bank. He gives the bank teller $163.75. And he says, I want as many $50 bills as you can give me. How many $50 bills does the banker return?
3.
Why did you say 3, which is correct?
Why? Did
Yeah.
I say 3?
Yeah, why did you say 3?
Because 50 goes into 163 whatever 3 times.
3 times. It really goes into 163 3 point something times.
Right.
But why didn't you include the point something?
Because it's not part of the.
It's there's only certain number of 50s that you can pull out, which is exactly what you're articulating. Very good. Can't cut a 50 in half? Here you go, sir. I'll take this 50. No, don't do that. First of all, you're breaking the law. Second, that's unusable. So how do you do that? You take that number and you cast it as something else temporarily. You take that 163 divided by 50 and you cast it as a integer, even though those are doubles. We're going to talk about casting next time. All right, so this is Professor Robert Solis. Hope this video lesson was helpful. Have a good day. See you next time.